go. Now we're recording. Say hi to everybody.
Hello, everyone. So here is,
Let me open up my
oh,
quick.
yes.
Let me go ahead and open this up.
You have two number fours.
Yeah, I saw that yesterday, and so one of them is 5. Is actually number 5.
Good.
Sorry about that. That's my bad. I didn't realize that, and then if I go back in there and try to change it, it's gonna. I don't want to chance it. I figured, you can figure. You all are smart enough. Figure it out. All right, number 4. Oh yeah, that's one of those where you have to.
Well, which is number 5 now?
Yeah, number 5. Yeah.
Because it says the raw score corresponding to a z-score. So we're trying to find the raw score, which is the x value here.
Right. Let me share my screen.
Oh yes.
Whoops. Where is my? Oh, here it is. Up here. Okay. Here we go. So number 5. Number 5.
Yes.
So you're looking at the raw score.
We're looking at the
raw score corresponding to a z-score of 0.
Yes.
This is one of the easier ones because based on the formula, if you take a look at the formula that says x is equal to x is equal to mu plus z times sigma.
Yes.
Right? This is your z, right? 0 is your z. And then mu is 60 and sigma is 4.3. So it's really just a matter of plugging in numbers where they correspond.
So just x equals 60.
Hi, Elmira. Yeah, pretty much. Yeah. So it's mu. It's going to be mu. It's mu plus sigma, which is 4.3 times 0. So whenever the x, and this is something that I want to make sure that everybody understands, is that when you have a z-score equal to 0, what this means is that it's the mean.
The mean, okay.
Remember that the z-score is the distance, right, in standard deviations, right? It's the number of standard deviations you are away from the mean. So if you're 0 points away from the mean,
you're at the mean.
You're at the mean. Yeah, exactly. Right?
Okay.
Exactly. And this is telling you that you're 1.51 points below the mean.
Correct.
Right?
And then now the third is the z-score corresponding to a raw score. So then now we go back to
the z formula. Yeah. So it really depends on what the question is actually asking you, right? So if the question is asking you for the raw score means the x value.
Great.
And the z-score, well, then that's the z, where you're looking for the z value, right?
Value. Okay, cool. Can I ask you another one?
Of course. And anyone who's got a question, you can either put it on chat or, go ahead and blurt it out. So go ahead, Rooster.
Sorry, on number 9, Jake is having a party. He stacks his fridge with beers and bottles and Coke.
Yep.
So when it asks randomly the first beverage, now everything is all in a bunch. So the beer, the Coke, the wine coolers, is that the total?
Yeah, so the first thing you would have to do is figure out what your N is. What's your sample, right? How many bottles does he have in that fridge, right? So you have to total those up, and that's your N. And then you add up the number of beers, right? And then divide that by the total number of bottles, because that's your sample space, right?
Great.
You got 12 bottles of Coronas, 24 bottles of Shock Top, and 24 bottles of Heineken, right?
And then the amount of beers is the 12 of Corona and then the 24
right?
Oh,
24 and 24, yep.
24.
So 48 and 12
Great.
divided by the total,
The total.
all the bottles.
Okay, so it'd be us adding 24 plus 24,
Well,
which
it's going to be the Coronas, right? 12, 24 Shock Top, and 24 Heineken. Well, it's asking you, right? So basically what you have to think about is, okay, so it's asking us what's the probability that Jake goes in there and grabs a bottle of beer, right? So it's the same thing when you're playing cards, right? You got a deck of 52 cards. What's the probability of you pulling out a particular card, right?
Okay.
Right? So it's the same idea. It's just here, I don't tell you what the total number of bottles are. I give you the different types of bottles that are in there and the number of different types of bottles. So all you need to do is add everything up and then divide, right?
Okay, great.
Yay.
On number
Don't make it harder than it is.
on number 15, the one that we didn't do was the P not E in parentheses.
Yes.
Now, why do we not include the not E column?
No, it's asking you for the probability that someone has no coffee experience. That's the not E.
Is the column.
Yes.
Ah. Like, oh my God.
What does that mean?
It was midnight. I went to sleep. Okay.
Yeah, so not E. So notice how I put little symbols because it's easier when you're trying to, I don't want to write the whole thing out. So I usually use symbols. So yeah, so E stands for experience. Not E stands for no experience. Just like F stands for full-time and not F stands for part-time.
Okay. Very good. And now 24.
Okay.
Okay. So 24 is the
Yes.
teaching supplies.
Uh-huh.
Now for 24, the formula, oh gosh, I just had it right here.
So the first question I would ask you, what is different about this particular problem versus the other problems that you've done?
Oh, this is the standard error of sample mean. We're looking for
right. Yeah, and what key terms in this problem is telling you that you're going to have to use a different formula than the one in Chapter 5?
a random sample of 50 public school teachers.
Right, exactly. Okay, so as soon as you see this right here, random sample of 50, right? A sample of 50, you know immediately that you have to calculate standard error of the mean, which is sigma divided by the square root of n.
Correct.
So that should immediately highlight that. Just like in number 25, right? You have both a randomly selected pregnant woman. Oh, okay, that's the just divide by sigma. But the second one, the random sample of 20, now you have to do standard error.
So, Professor, I have a question.
Yes.
Would it be this formula right here? I don't know if you could see it.
Yes. Yeah, I could see.
Yes.
Okay.
Yes. Yeah. Yeah. So it's the sigma. It's the one that says sigma m, which is, hold on. Let me go into real quick. Go back into student view. We'll just do real quick, just like we did yesterday or last night. Assignments number 3. So it's this, right? It's the sigma m. I'll write it out so you can see it, right? Which is equal to fraction. There you go. Right? So whenever you see in the problem, if it tells you that you're dealing with the random sample of any number, you need to actually use this formula that's in that denominator, right? So I always recommend that you figure out this first and then go ahead and figure out your Z score.
The N here is at 50?
Yeah. Well, what does it say?
Well, so what is the probability that a random sample of 50 public school teachers spends an average of more than $400 each year? So N is 50, sigma is 175.
Oh.
Is that right?
Yeah, no, I'm yes, yeah.
Okay, and then where does the 400 come into play? Is that the M, the big M, in the second formula? The Z equals.
Yeah, that would be your mean. That would be your M. Yeah, exactly. So basically, what it says. So you've got mu, right? You've got sigma. You've got N right here, which is 50, and then your sample. See, because this is the sample, okay, and this is the mean that we got, or it may not be the mean. Well, I guess it would be the mean. Yeah, it would be the sample mean for this sample of 50 public school teachers. Okay, so yes, that would be the M.
So, Professor, I have a question.
Yes.
So the answer for the standard error, I believe, I always get the names confused. With the thing that looks like the O and the N, the first formula.
Oh, here?
Yes.
Standard error of the mean?
Yeah, standard error of the mean. So would the answer be 7.07? Or am I doing that wrong? Because I'm doing, I don't know if I got the numbers wrong, but I'm doing 175 divided by the square root of 50.
So you're doing 175 divided by the square root of 50, and the square root of 50 is, it's not a great, fabulous number, so it's 7.071. And one of the things that I will recommend is that you leave your numbers out when you're doing this. So when you're actually, so let me go in here real quick. Right, so you've got your formula, right? And so when you're doing this, it's going to be 175 divided by the square root of 50, right? So this is going to be, again, 175. But here, what I see a lot of students do is they round up way too soon. So they'll start rounding up here, and so they'll put like 7.07. But what you need to make sure you do is that you actually leave it out. And you can actually round it to the 4 decimal places. And the reason why I say that is because what's going to end up happening is the sooner you round, the more inaccurate your z-score is going to be. Okay? So you want to make sure that when you're rounding, you round at the end, right? So the 175 divided by 7.0711 gives us, is that right? 24.7486. Did everyone get that?
Yes.
Cool. And so now we can go in here and we can actually do the m minus mu, right? So it's going to be 400 minus 443. And so immediately, what do we know? Is this going to be a positive or a negative z-score?
Negative.
Yep. Negative, right? And why do we know that?
Because you can't subtract 443. I mean,
Is 400 larger or big or smaller than 443?
smaller.
Smaller. So that's how we know, right? So 400 is to the left of the mean, which means it's going to be it's below the mean, and so it's going to be a negative z-score. The reason I want you to stop and think about that is because as you're working through problems, if you're coming up and you're going, wait a minute, why do I have a positive number here? That's a quick check, right?
Mm-hmm.
It's a quick way for you to double check your work and make sure that you're doing it correctly. Okay? So this is going to be negative, which is negative 43, right?
Mm-hmm.
Divided by 24.7486. And so this is equal to, don't forget the negative number, or negative sign. The 43 divided by 24.7486, which gives us negative 1.737. And here, remember that in the Z table, our numbers are to 2 decimal places, right? Are you guys there?
Yes.
Okay. So we need to round this up to 2 decimal places so that we can look it up on the unit normal table.
So does it come out to 1.74?
Negative 1.74, correct.
Let's see.
Right?
But we write negative 1.74, but it's all positive when we look at the z.
Yeah, because what happens on one side of the distribution is the exact same thing that happens on the other side of the distribution.
Right.
Right? So it doesn't matter. So when you're looking up on the Z table, there are some Z tables that actually have your negative numbers and your positive numbers, but in our book, it's all positive numbers because it's just, you know, it's redundant to have the negative and the positives because what happens on one side happens on the other side. They're symmetric, right?
Yes.
So whatever happens on one side is going to be the same thing that happens on the other side.
Okay.
Okay.
So 1.74.
And I have another question.
Here it's asking you more than 400, right? Each year. So is this, are we looking up now? So the here, are we looking in the tail or the body? So here, remember, we're looking for the probability that X, or actually that M in this case, right, is larger than 400.
So I'm assuming it would be in the tail because it's like towards the negative. Right?
Draw it out.
Let's see.
Remember how in the sample examples in the modules, in the videos that I have in the modules, under lecture videos, the samples, you always draw it out so that you can see what's happening, right?
Yeah, so it would be in the tail. No? Okay. Because I have it right here.
Think about, okay, so even looking at the numbers, right? If your mu is 443 and your M is 400 and you're looking for the probability of teachers spending more than $400, right? Is 443 in that in that area under the curve? So when you draw it out, right? So I'm gonna do it with my fingers because I don't have Wi-Fi in my office, and so I can't log into Screencast and then actually write it out for you. So I'll do it with my fingers. So draw the line, right? And then draw the curve. Okay? And then in the middle, mu is 443.
Yes.
Okay. Is 400 to the left or to the right?
To the left.
To the left. Okay, so draw a line where 400 and put 400 there.
Okay.
Right? Now it's asking for more than. So are you going to the left or to the right?
For more than 400?
For more than 400.
You're going to the right.
You're going to the right.
Yes.
So is the mean included in there?
Yes.
Yeah. Right? Because it's so if the mean is included, that means it's in the body, not the tail.
Okay.
Right?
Oh, okay, yeah, because that's what I get confused with, because
Yep.
it's saying greater, and I'm thinking, which was the
You're
negative
thinking that you're on the right side. If this were, instead of 400, let's say this was 500, and that's already to the right of the mean, right?
Mm-hmm.
Had that been $500, right? If this number here, if the mean had been $500 instead, right? Then yes, it would be to the right of the population mean.
Mm-hmm.
And yes, then that would be the tail. Because more than doesn't include that mean, right? Because at 443, and you've got 500 over here, right? Then to the more than, then that's in the tail.
Okay.
But because you're on the left side of the distribution, right? At 400, this includes that 443 and then beyond. So that would be the body.
Okay.
Now, had we asked less than 400 instead of more than, that would be the tail.
Yeah, because that's what I was getting confused with, because I'm thinking, because it's the z-score is negative 1.74, so I'm thinking it's less. So I'm thinking it's all the way in the tail instead of all the way in the bottom.
Right. Yeah, it really is about which side, right? If we're looking for more, that means it's got to go to the right. If we're asking less than, then it's got to go to the left.
Okay.
Did you find the number?
Oh, to look it up?
No, I mean, I looked it up. I was wondering if she found it. I don't want to stop her from her.
Oh, no.
Looking, when we look at, so this is a probability that z is greater than negative 1.74, right? So our p is equal to, and it's going to be point something.
9591.
9591.
Yes, in the body of 1.74. Yes.
Huh? There you go.
Okay.
Woohoo!
And this is all lowercase p.
Yeah, lowercase. Correct.
Okay.
Yep. Because when we start reporting it out, yeah, it's going to be, we're going to report it out with a lowercase, and it's really italicized as well. But for now, lowercase, we'll leave it at lowercase. And then when we get to chapter 8 and 9, then we start to italicize it when we're reporting out results.
So, Professor, there's two more formulas on the formula sheet. The z equals x minus the mean
X minus.
over s. I mean, x equals x minus. Z equals x minus m. So this is for the sample mean.
Wait a minute. Let me take a look at it. Okay. Oh, you mean this one here?
You know, somehow I cannot see what you're seeing. I don't know this time.
You don't see the formula sheet?
So
you're talking about on the right side of the formula sheet where it says
the z
x minus m divided by s. So what's the difference between these two?
So this is for sample mean.
Right.
The other one was the population.
Right. Yeah. So if a problem So basically, rather than using parameters, if one of the problems gives you statistics, right, sample statistics instead, where they give you an M and an S, then you would use this formula. It's the identical formula. It's just that the symbols represent something different.
Okay.
Right? So if we're dealing with population parameters, if your problem is talking about population mean mu and population standard deviation sigma, then these three formulas on the right, on the left, are the ones that you're going to be using, and also this one on the right as well.
Okay. Oh, Professor, I have a question.
Mm-hmm.
Could we work on number 14? Because I always get confused with the flipping the coin probabilities.
Uh-huh. Well, with probabilities, this one here.
Mm-hmm.
Yeah, so probabilities, it's just understanding, this is where you need to understand that no matter what, when it comes to random events,
Mm-hmm.
all outcomes are equally likely.
Okay.
As long as they're random events, then everything is equally likely. It's the same idea as when someone gets pregnant, right?
Mm-hmm.
The probability of having a boy or a girl is 1 in 2, right? So 50%, right? Or 0.5, okay? Now, we tend to say something to the effect of, well, this person's had like 3 girls in a row. They're due for a boy. No, they're not. It's still a 50% chance, right, that they're going to have a girl or a boy, right? The probabilities don't change, right? Because they're random events.
Okay, so would the same apply to number 10, like the 10 through 13 about like the deck of cards? Those would still apply, right? Like the rules?
What do you mean, the rules?
Like how you said right now, random events, they're
These
all
are all random events, yeah.
okay.
Yeah, and this is basically where you draw a card and then you replace it, right? So what's the probability? These are separate decks, right? So drawing an ace out of a standard deck of 52 cards, right? So so as long as you understand that there are 4 aces, right, in a standard deck of 52,
Mm-hmm.
there are half of the cards are red, half of the cards are black, right?
Mm-hmm.
And there's 4 cards of every suit, right? So there's four cards, there's 4 2s, 4 3s, 5, and on and so forth, 4 kings, 4 jacks, right?
Mm-hmm. Okay.
So it's really understanding how many of each card there is.
Yeah, because again, I don't play cards, so I'm like, how much are there? So I'm like, I feel like I should get cards and be like, okay.
Yeah, there's 4 aces, right?
Mm-hmm.
You've never played poker, if you've never watched poker or blackjack, or
I've played, but I don't pay attention to how many cards are there. I'm like, okay, I
if
have
you get 4 aces, that's a good hand.
Yeah.
Yeah.
Yeah. Okay.
Yep. And then there was a student who had emailed me and wanted, I'm gonna do a quick stop share because I want to go take a look at the email real quick, because she wanted me to go over some problems. Let me go back in there and check out which ones she wanted me to look at. Okay, so it looks like, let me write them down real quick.
Oh, Professor, is it okay if
Yeah?
we don't meet up today, like me and Alex, just because we're in Palmdale?
Yeah, of course.
Okay.
You don't have to come. It's okay.
Okay.
It's not mandatory.
I know, but I feel so bad.
Don't feel bad. It's all good. No. All right. So we're back over here. Let me go back to my Zoom and then go back to sharing screen. Okay, so we're back here. All right, so one of the problems was number 7. So with this particular problem, I think we talked a little bit about this on, let me go ahead and copy it and put it into.
Guys, I'm here, but I just have to step outside to show the gardener.
Okay, that's fine. Okay, so number 7, it's one of those where we have to work backwards, okay?
Okay.
So we know that the distribution has a mean of 50 and a standard deviation of 5, right? So we need these 2 numbers here. So I'm going to go ahead and highlight them because these are important, right? Important pieces of information. Oh, whoops, that was the wrong thing to do. Let me go back and change that because now I can't see what that says. Sorry. Oh dear. Black, and then go back here and do highlight. There we go. Okay. All right, now we can actually see that. Okay, so the question that is it's asked here is the z-score cuts off the top 10%, right? What's the z-score? So we need to figure out what the z is, right? So we need to work backwards. And so remember the curve, right? So when you draw out the curve, right, the standard normal curve, what we're looking for is to the right of the mean, right? So you put your mean in the middle there. And then off to the right, the top 10%, right, it's going to be to the right of that mean. And what you need to do is just highlight, draw a line through there and just kind of, not highlight, but shade in the 10%, right? So 0.10 is the area under the curve, right, that we're looking for. And we need to find the z-score that represents that area equal to 0.10. You follow me so far?
Mm-hmm.
Yeah? And so what we need to take a look at is the z-table. And I don't think I have it here. I have to go back. Let me open up another screen real quick.
The z-table, would it be the equals
The unit normal.
Yeah, over the mu over what looks like the circle and the m.
I'm sorry?
For the formula, would we be using this one right here, the bottom one? Or the top one?
Well, are we dealing with a sample?
We're dealing with a sample?
Does anything in there say anything about sample?
Let me double check. Number 7. It says we're dealing with a mean, so I feel like it would be a population, right? Or am I wrong?
Yeah, it's going to be the population mean.
Okay.
So going back to where we were, right? So basically, we're looking at P. We're looking for the Z that cuts off. So let me write this out. So we're looking for the z-score that corresponds to P greater than 0.10. Probability, right? P, probability greater than 0.10. That's what we're looking for. What is that z-score? Okay? With me so far?
Yes. So I have a question again, Professor. When it comes to like the questions that are like backwards, like number 7, do we always have to put what you just put right now, like looking?
No.
Okay.
No, absolutely not. I'm just writing it out so that you have it, so that you know, okay, so this is what I need to look for.
Okay.
Okay?
Okay.
So this right here, P,
Mhm.
right? So what we're going to need to do is take a look at the column that has 0.10. Now, my question is top 10%. Is this in the tail or the body?
Let me see. I have to draw
It's the what?
it out like you said, so I know.
Yep.
Okay.
Draw it out.
50.
Put your mean, and then what's the top 10%? Is it going to be to the right or to the left?
It's gonna be to the right.
The right. Yeah, it's going to be a small section to the right, right? Probability. So basically what you need to do is just shade in a small area, and then P, you're going to look for P greater than 0.10. And so now we need to go to the Z table. But is it in the tail or the body?
I want to say it's in the tail because you said
It's in the tail. Does it include the mean when you shaded it?
Oh, I didn't get to that part. I'm just going.
Yeah, the top 10% is not going to include the mean.
Okay.
Okay. If it said the top 90%, then yeah, it's going to include the mean because the mean is 50%. So when you look at the distribution, right, remember that mean, that z-score equal to 0 and mean, whether it's sample mean or population mean, the mean always cuts that distribution in half, where 50% of the scores are going to be to the right and 50% of the scores are going to be to the left.
Okay.
So so if we're looking for a probability that's higher than 50%, your mean is included, it's going to be the body. If we're looking for a probability that is less than 50%, it's always going to be the tail.
Okay.
Okay? That's another little, it's kind of like a trick or a hint, I guess, that helps, right? Okay?
Okay.
Cool. So let's go to the table. We're looking in column C, which is the proportion in the tail, and we're looking for probability 0.10. So we need to keep going, scrolling down until we get to 0.10. We're getting close here. Here we go. So it's between 0.1003 and 0.0985. Which one is the closest to 0.10?
0.0985.
This one here, right? Yeah, am I right? 0.1003 is the closest to 0.1. So the z-score, the z cutoff is 1.28. So at 1.28, this is where the top 10% start. This is the cutoff. So going back to the lab, right? So I'm going to get rid of this because we don't need that. So the z is equal to 1.28.
Okay.
And then the raw score, so what's the formula for the raw score? What's another word for raw score?
I have to go through my notes because I always put it in like the little PowerPoints.
Anyone chime in? What's the formula for finding the raw score? So if you look at your formula sheet, let's see. Which one of these is your raw score formula? The first row, the second row, or the third row?
Wouldn't it be the third?
It was, or the second row?
Second row. The X value is the same thing as the raw score. Okay.
Oh, okay.
These are Z scores, right? So anything with a Z, no, that's not an X value. That's not a raw score. This is your Z score. Okay. So
okay.
this is the one that you're going to want to use is X is equal to, okay? So X equal to, and it's mu plus Z times, Z times sigma, right?
Mm-hmm.
Which is equal to, so the mu is 50 plus, what was your standard deviation?
5.
5. So 1.28 times 5, right? And then you can figure out the rest of it, right? So 50 plus, don't forget the equal sign. Whatever 1.28 plus 5 times 5 is?
I got 56.4.
1.28 times 5?
Mm-hmm.
No, that's 6. What's 5 times 1.28?
Oh, I got. Oh, okay. I
6.4.
accidentally typed it wrong.
6.4?
Yes.
Okay.
Is that right?
Yes. Oh, okay. Because I accidentally put 50 plus 1.28 times 5. That's why I did. I didn't do
Okay, yeah.
parentheses first. Okay.
And then so this is 56.4, which is the correct answer. So what this tells us, so what this means, and it's important to understand what this means, right? So what this means is that this X value, 56.4, is what cuts off the top 10% of the distribution. So let's say, for example, let's say that this is the ACT test, okay? And we've standardized all of the national scores, okay? And we want to know what the top 10% of that ACT distribution is, right? Well, the score that would actually cut off the top 10%, right, is 56.4. Anyone below that, right, that's going to be your 90th percentile, right? So if someone scores a 56.4, you're at the 90th percentile. And 90% of individuals, basically what this is telling us is 90% of individuals did worse than you did. Does that make sense?
Mm-hmm.
That makes sense.
Yes, no?
Makes sense.
Are you sure? I'm like, wait, don't say yes if you're not understanding it. I mean, when you look at SAT scores or any of the exit exams that you take, right, you'll get like your scores back, right? And it'll tell you, oh, you know what, you're in the 95th percentile. Woohoo! Yeah, that's great. That's fantastic. Basically, what that's telling you is that 95% of the people who took that test did worse than you.
Really? Wow.
Yeah, that's exactly what it's telling you. So you're in the top 5%.
Oh, interesting.
Yeah.
Okay.
Yep. And we use Z-scores to figure that out. It's like the real life application of Z-scores, right?
Okay.
So there you go. So that's number 7. That's how it's done. Okay. And then 17 was another one that, let's take a look at 17. Ah, yes, we did these yesterday. So it's just, I actually showed how to do this one yesterday. So if you look at the recorded review session that I posted, the YouTube video, we actually walked through this one a little bit, right?
I remember us doing that one.
Yeah, the gestation period, right? The random sample. So this is your normal Z, right? You have to figure out what the Z score is, and you're going to use the X minus mu divided by sigma.
Mm-hmm.
And then this one is where you have, because we're dealing with a random sample, for the last two, then you have to figure out your standard error of the mean, your SEM. Right?
Which, I'm sorry, I'm back. Which number are you doing?
17 we did yesterday. So this is one of your classmates had asked if we could go over some questions in this review session because she wasn't able to. She was on chat or something was going on with her microphone, and so she couldn't voice what numbers she wanted to talk about. And so I'm just kind of going through and looking at the ones that she wanted us to look at. So.
Okay, great.
Yeah. And then 16, this one's an interesting one. So this, actually, let's take a look at number 16. This one's a fun one. Okay. So, so this one, I mean, these first two, these are pretty straightforward. I've shown how to figure out the z-scores and how to look up the probabilities on the z-table in the previous one. But what we haven't done is looking up z and calculating z's and looking at probabilities for magnet when we're looking for between two z-scores. We haven't done that yet, right? Okay. So here, what we need to do is we're going to need to find two z-scores. We need to find a z-score for 5.8, and we need to find a z-score for 7.1. Okay? And my suggestion is to draw this out. Okay? Because it's going to be easier to figure out, okay, so where do I look, or what column do I need to look at in order to tell me what the probabilities are. Okay, so draw this out. So remember, draw the line, draw your curve. Okay, and in the middle, your mu is equal to 6.2. So put mu equal to 6.2 there in the middle and draw that line.
Mm-hmm.
Okay, 5.8, is that to the left or to the right?
Left.
Left. So draw another line, 5.8, put down 5.8 to the left of 6.2. And 7.1, is that to the left or to the right?
Right.
To the right. So again, draw another line and put 7.1 to the right. Now notice, okay, that now you have two areas, right? One to the left of mu and one to the right of mu. Is that what you see on your drawing?
Yes.
Right, so you've got two areas and they're both on either side of the mean. So what this means is that when you go to look up probabilities, you're going to look for the mean to z, which is column D, and then because they're side by side, they're on either side of the mean, you're going to add them up. You're going to add these two probabilities because you need that whole entire area. And that's going to be your probability.
So I have a question, Professor.
Yeah, you're going to, okay.
Where
Yes.
it says 5.8, you said it's in column D, right?
I can't hear you.
Can you hear me?
Yeah, now I can.
Okay. So how it says 5.8, this is where I get kind of like confused a little bit. Would in column A, would we have it as like 0.58 and then from there we would look?
No, we haven't even done the z-score yet.
Okay, yeah, that's where I get
This
confused.
is where you draw this out. These are the actual raw scores, right? These
Okay.
are the x values.
Yeah, because I drew it out right now. That's why. And then under the raw scores, I know it's 0 and then 1, 2, 3, 4, 5.
No.
No?
Those are z's. No,
Okay.
for this, when you're drawing this out, okay, you're gonna just put the mean is equal to 6.2, and then on either side, on the left, you're gonna put 5.8, and then on the right, you're gonna put 7.1, and then you're gonna write that area in.
Okay.
Okay.
Professor, before
Yes.
you go on, at the beginning, the magnitude of the earthquake since 1900 that measures 0.1 or higher.
Yeah, that
Where
is just, we've been measuring earthquakes since the 1900s. Anything that is 0.1 or higher on the Richter scale. So we have a lot of data about the earthquakes in California.
So, but this 0.1.
No, that's irrelevant.
Okay.
Yeah, this is where you have to figure out, okay, so what's irrelevant here and what's important, right? So what is relevant is anywhere where you see mu. Okay. And then we're going to go ahead and highlight, and sigma. Okay, that's relevant. That is the only thing that's relevant here in this area.
Okay.
Okay.
So would we be using, let me look at it again. So much tabs.
What?
Because I was looking at the formula sheet and like I have to go through all my tabs to make sure. So would we be using
What numbers do you have? What symbols are we using?
population?
Yep. And it's a one randomly selected earthquake, right? So it's not n equal to 50 or 49 or 25 or anything like that, right?
So we would be using the first formula to the left,
Yes.
right? Z equals.
Yes. Yep. So we're going to go in here. It's going to be Z equal to, and it's going to be X minus mu over sigma, right? And you're gonna have to do this twice because you have two numbers, right?
Okay.
You have two X values. So we have to figure out what's the cutoff? What is the actual Z score for both of these so that we could look it up so we can look up the probabilities in the Z table,
Okay.
right? So what was it? 5.8. Go back here. So it's 5.8 minus 6.2 divided by 0.5.
Okay.
Right?
Yes.
Right.
So 5.8.
Negative 0.4.
Yep. So negative 0.4 divided by 0.5.
Negative 0.8.
Cool. So this is going to equal to negative 0.8. Don't forget the negative signs. It's one of the things that sometimes happens. Okay. So there's the first one. Okay. So that's one of the Z-scores we're going to have to look up in the table. The second one, so we got to do the second one. Go back up here. So again, so Z equal to minus
So 7.
divided by sigma, right? Which then is equal to
7.1 minus 6.2.
excellent, 7.1 minus 6.2 divided by 0.5.
Which is 0.9 divided by 0.5. 1.8.
That's a positive number. Okay, so now we have both of these, right?
Mm-hmm.
Okay. So now we've already established that this is mean to Z. We're going to look for the probability from the mean to the Z and then probability from the mean to the Z, right? Because that's what we're looking for, those two areas, okay? There's multiple ways of doing this. You can, but I think the easiest way is just to look up the actual mean to Z's here.
Mm-hmm.
So let's go to the Z table. So we're going to look for 0.8, mean to Z.
It's 22881.
0.2881. So I'm going to just put it over here. Right. So this is going to be, oh, is it letting me?
No.
Oh, it's not going to let me. Oh. So the Z equal to negative 0.8. So P is equal to 0.2881. And then Z equal to 1.8. P is equal to 1.8. Go down, 1.8, 1.8, 1.8. Mean to Z is 0.4641, right? And then based on our drawing, we need to add these two numbers in order to get the actual probability for these two scores, for these two magnitudes. So it's going to be 0.7 something.
Here, I'll do it right now. 0.2881. 0.1. Actually, I have 0.7522.
Mm-hmm. 0.7522. Okay. There you go. Okay. So that's how you do the between. Okay. So anytime you have a between, that's one of the ways. Now, if both of these numbers, let's say that instead of 7.1, let's say it was 5.8 and 6.0, those are both below, right?
Mm-hmm.
And so the probabilities that you would get, you would have to subtract them instead of adding them because they're on the same side of the distribution. So anytime your Z's are on the same side of the distribution, right? So they're all on the they're both negative or they're both positive, you're going to subtract those probabilities.
Ah.
Yeah.
We gotta pay attention.
Yeah, I mean, that's why I say draw it out, because it makes more sense when you look at it. When you actually take a look at the drawing, it makes sense, because if everything is on one side of the distribution, your mean to Z is going to include an area that is already counted by one of the probabilities, so you have to subtract that out.
That makes sense. Good.
Okay.
A question?
Yeah.
I guess on the last test, what really was difficult for me was the inferential, and then which one was this? Which
The
one?
interpretations.
Yes, and there was quite a few, and I think I got maybe a couple of right. I think I lost most of my points from there. On this exam, is there going to be things like that where we have to do the multiple choice of recognizing, or not like definition, but
no, it's applied. It's understanding. Yeah, it's understanding what it is that you're doing. Yeah.
Okay.
Yeah, most of my tests are like that. I try to put in a couple of definitions here and there, but really it's about, are you understanding what's going on, right? Can you apply it?
Okay.
Because the same thing with
there's
me,
going to
like,
be applied stuff.
I understood most of it, but some questions, like, I thought in my mind I flipped it. So like how I said, what's the numbers? I think I put inferential when it was supposed to be. Yeah, that's what I did with some of them. And I was like, oh, and then when I read back the notes, just because again, like that happens to me, like when I get under pressure, sometimes like I read it fast and I don't like take the time. So, but yeah, I have to
remember what I said in yesterday's recorded review session. Make sure that before you start, my recommendation is to go and do the calculations first. Okay, so make sure you go through those, get those done, do the ones you know, right? And crank those out, get them done. And then go back and do all of the multiple choice, and watch your time, because 2 hours goes really fast when you're starting to look stuff up and trying to find information in your notes, and it goes by way too fast, and all of a sudden there's no more time left and you're like panicked because you've got like 10 minutes to do 3 problems. And so that adds stress level, and it also affects your performance, right? So my suggestion is, when you first start out, do the calculations, do the ones go through all of the multiple choice, do the ones that you know. Okay, go through and go back, for the ones that you don't know, then go back to those, right? And then look those up. That way you get through everything that you know, and then you can spend a little bit more time with the information that you might need to be looking up.
Okay.
Right?
Are you?
But my thing would be practice. Practice as much as you can. Do the odd numbers in the back of the book, right? The end of the chapter problems, the odd ones, they have answers to those, right? So look them up and double check and practice as much as you can, especially with the labs and the types of things that I'm asking you here, because these are what you're going to see on the test.
Okay.
And then don't forget that I'm also going to ask, and I talked about this last night, about I'm going to ask some questions where a particular probability, right? So is this unusual? Why or why not? Right? So a probability of 0.9591, is that an unusual event?
Okay.
Right? And so the answer to that would be absolutely not, right? Because it's not less than 0.05, and the z here is not bigger or smaller than 2.
Oh yeah, I wrote that in number.
Yeah.
I think number 17 was the question where it says about probability, and I put yes, it's unusual because the probability is less than 0.05.
Number 17.
Yeah.
Oh yeah, that's right. Yeah, we did that yet last night. Yep. I wrote it out so that you could actually see what that looks like. Yep. Yep. And then the other questions that were written down here are stuff that we did yesterday. I think are pretty. I mean, they're all the same thing. You're just doing the same thing over and over and over again, so that you get used to it and you get good practice.
And are we going to see the answers for this one, just to?
They're already there.
Oh,
Most of them. Yeah, I was up till 1 this morning.
My gosh.
Yeah, I was up till about 1 o'clock this morning. So yeah, I've already opened them up. I went ahead and opened them, so the answers are there.
Okay.
Yep. Yeah, so you can double check your work. Yep.
Okay.
Yep. So does anybody have any other questions, or?
I think I'm fine. It's just, again, I told you, my, I guess insecurity, I guess it's probability, but I'll go and like double check and review that chapter really well. That's, again, my only really like issue or my concern. But everything else is pretty like understanding. It's just it's just plugging in the right formulas. And again, like you said, population is Greek, and then the non-population is just like regular letters. So
Right, sample's going to be your normal Roman alphabet.
okay.
Yep. You got it. Yep. Like this is population, right? Easy peasy. Yep. Yeah. And probability is so basically what we're doing now, up until this point, we've been doing all of descriptive statistics, right? So everything has been describing. Probability is where we start getting into the inferential stats. So this is the bridge. Now we're coming to the bridge, right? Of okay, now we're gonna cross over from descriptive statistics into inferential statistics, and chapter 8 is all about inferential stats.
Okay.
Yeah. So the probability is super important to understand, because statistics is all about probability, right? How certain are we, right? So hopefully with a 5%, with 5% certainty, with 95% certainty, we can say, yeah, I'm pretty confident. I'm 95% confident that this result is what's going to happen
Okay.
in the population based on the sample data. Now, that doesn't mean that it's 100% accurate, right? Because 95% is not 100%, right? So there's that 5% error rate that we have.
Yes.
And that's with most of the social sciences, we use a 5% error rate. In the medical industry, you'll typically see like 1%. So they're really tiny. They're much smaller error rates because of the field, right? So when you're testing and when you're doing, like say for example, you're doing pharmaceutical testing, you don't want a 5% error rate.
Yeah.
Right? That 100, out of 100 patients, 5 of them die. No, that's unacceptable. Really, we want that number to be 0 and as close to 0 as possible, right?
Mm-hmm.
But in the social sciences, when we're dealing with behaviors or in politics or in when we're doing trend analyses and in society, divorce rates and things of that nature, we're okay with that 5% error rate. We're okay with that.
Okay.
Yep. So yeah.
I have one question. Now that
Sure.
you've recorded this,
Yes.
how do we go about to go over the recordings? Where do we find the recordings?
Oh, I'll show you. I can show
Yeah,
you.
that was my question too. Thank you for
I
asking.
can totally. That was your question too, Elmira?
Yeah.
Yeah, okay. So at the very end, so here was last week's module. Actually, no, here's yesterday's is right here. It's at the very end.
Oh, it's called ConferZoom.
ConferZoom 729. So this one's going to be ConferZoom 730 review session. So it's a YouTube video. So when you go ahead and launch it, it's going to launch it in a new window. And there it is.
Ooh.
So this is at my house last night. Yeah, so there you go. So that's the ConferZoom.
Awesome.
Mm-hmm.
Yeah, it really is. I'm like, oh my God, this is so freaking cool.
Mm-hmm.
Now I'm like there for prosperity. And so are you.
Yes.
I get to see your faces.
So we're good to see you this afternoon at 5.
Yeah, 5 o'clock this afternoon. If you can make it, come. I'm gonna send out a quick announcement. It may just be you, Parastu. So we might just hang out in the office, or we'll go into the room and we can work out some problems on the board, and I can show you some of the stuff.
Okay, thank you.
Yeah, of course, no problem. Yeah, I'll be here. I'm not. Yeah, I've got to finish grading all your stuff. I'm like, oh my God, I feel terrible. I've had so many things happen in the last like 4 days. It's been a nightmare.
Well, it's fine. It's life. You can't.
Yeah, life happens.
Yeah.
I'll tell you.
Okay, we don't want to see our grades, Professor.
No, you do. You want, well, the grades actually aren't that bad. I'm looking at them and I'm trying to be as generous as possible. And that's the other thing too, is I take a lot of breaks and stuff because I want to make sure that I'm being consistent in the way that I grade stuff. So I like to go back to it refreshed and when I'm going through and grading stuff. And so yeah, so that's why it also takes me a little bit longer. But with the exams, I'm almost done. I think I have 10 more to go with the exams, and then I've got all the labs. So I'm going to get those done between now and 5 today, so that you guys have all that feedback, so that okay, so this is what is expected, right?
Yeah.
And so yeah. So hopefully that helps.
I actually have a question.
Yeah, you have a question?
Yes. For
Okay.
how the recent question we did, I think it was what number was that?
16, I think.
The earthquake one?
Yeah, the earthquake one. Yeah, 16.
Okay, let me go back to, all right.
When you were doing the magnitude between 5.8 and 7.1, and we
Yes.
found the Z.
Yes.
So my question is the proportion part. When you go into that chart,
Yes.
so the proportion between Z and the mean, what, I guess I don't, like, how would you know, like, that's the proportion between Z and the mean?
Right. That's because when you draw it out, right? So look at this drawing right here.
Okay.
Okay. So basically what we did, right? So if you look at 0 here, right? So the 1.8 would be here.
Okay.
And the negative 0.8 would be over here. So the proportions that we're looking for is from the mean, which is here, to the z-score. And then the mean here to the z-score here.
Okay.
Right? So there's another, think of another line here, and that's shaded as well. So you're looking for this area under the curve here, right? Because remember, the area is the proportion. It's the probability, right?
Yeah.
Area under this curve is equal to 1, right?
Okay.
It's 100%.
Yeah.
The percentage is 100% under here, right? And what's cool about the z-scores, right? When we transform a distribution into a z distribution, we can figure out what the probabilities are. And that's the reason why we use z distributions, is so that we know how many standard deviations a particular score is from that mean, right? And then we can actually figure out what that probability is under here, right? So if you notice, these are, take a look at these, right? So if it's the body, you're gonna have a negative z and the mean is included, right?
Oh,
That's
okay.
the body. Here, again, it's, when you look here, if it's positive, right? And to the left, the mean is included. That's always the body, right?
Okay.
And then if we're looking like here, positive, and we're looking to the right, anything higher than, it's the tail.
Okay.
And the same thing here, if it's a negative z and we're looking for lower, it's the tail.
Okay.
Okay? So draw it out. Draw it out.
I had
Practice drawing. There you go. Yes, that's exactly it. Yep.
Yeah.
You got it. Yep.
And
Yeah, so because it's just easier. I mean, you can do it. There's multiple ways of doing this. You could do it where you're looking for the body and the tail and subtracting them and all of that stuff. But with this particular table that we are using, it already gives you that proportion between mean and z. And I figure, you know what, it's just easier using that, using that column and adding or subtracting depending on what side of the distribution you are. So remember when I was saying if both of the z's are on the same distribution, so let's say you had a z here and then another z here, you have to subtract out this, you have to subtract this area from the entire area to figure out what this because it's counted twice. Right? So you have to subtract it out. So when the probabilities are all on the same side of the distribution, right, you have to subtract them. If they're on either side of the distribution, you get to add them. Okay? Yeah.
Oh, okay, yeah, because you mentioned
Right.
that you said if it's on the if on the same side we subtract. Right?
If it's on the same side of the distribution, right? Because remember, all of this is 50%. From mean all the way out, it's 50%. From the mean here all the way out, that's another 50%, which adds to 1, right, or 100%.
Okay.
There might actually be a question like that on the test. Just a hint.
Okay.
I hope everyone's watching these review sessions.
Can you say that again?
I'm writing.
I'm gonna put it in the announcement. Make sure you watch the review sessions. There's a ton of hints.
That's cool. That cleared it up. Thank you.
Well, because it's symmetrical. That's the big.
Yeah, exactly. Yeah, exactly. The mean divides this exactly in half, and if the area is 1, then 50% is below and 50% is above.
Okay. So again, if the numbers, the two numbers are on the same z-score, we subtract.
Mhm.
And if they're on the opposite side of the z-score, we add.
Well, opposite side of the mean.
Yeah, I mean, that's what I
The
mean.
mean, yeah.
Okay.
Mm-hmm. Yeah. Yep. Woohoo! Okay, you guys got this. I think so.
So I have a question. So during the test, we should be looking at our time, or does it, because I actually ended 1 minute before the 120 minutes.
Oh, wow. Perfect.
Scary. But I wanted to know what would have happened if I had gone over.
It would have stopped.
It would have stopped.
Yeah, you wouldn't have been able to go over 120 minutes. It actually stops it.
Okay. That was
Yeah.
really freaky.
Yeah, it stops. You can't take the test. I mean, it just stops.
Okay.
When the clock stops, you're done.
Clock stops.
Yeah.
Yeah.
So you want to make sure. I mean, you can be in there for 120 minutes and double checking your work and all of that good stuff, but
Yeah.
you don't want to be at 118 minutes and having 3 problems still to go.
Yeah.
That's my fear. It's like, oh my gosh. And the problems are really straightforward, and I tried to make sure that the calculations are relatively simple, hopefully. So, it's stuff that you could do in your head if you wanted to, but you had to show your work, so make sure that,
Okay. Yeah, the first set of problems were very long because we needed to.
Wait, on the test?
The first test, yeah.
You think
It
so? It was
Well,
long?
because you had to do the variance and then the mean
Yeah,
code and
yeah. Now this one is pretty straightforward. It's just there's nothing on the test where you have to actually calculate that out for yourselves. Yeah.
Okay.
Yeah. You'll have to calculate standard error. You'll have to calculate z's. You're gonna have to figure out what the X values are, all of that. Everything that you've been doing here, you're going to be doing on the test.
Okay.
Yeah. You should be okay. It sounds like you're understanding it.
Mhm.
We are.
Yeah. I'm sure you'll be fine. You guys got this. Elmira, did you have any questions?
No questions. I just have to go and review last night's recording.
Okay. So good. Okay, so everything is pretty straightforward. Good.
I have a question. Are you liking our discussion questions and answers when we answer our friends?
I haven't looked at the discussion number 2. That's after I finish lab 2, then I'm going to go into discussion number 2. I love the introductions. Those were awesome. But I got to go in and take a look at your discussions number 2. I'll put in some comments and stuff in there.
Yeah.
So I'll let you know if you're on the right track and
Good. How much in depth you want.
Right, exactly. Yeah, the next one, the discussion number 3 is going to be looking for advertising or ads and things of that nature. And so
that's pretty fun. I looked through.
Yeah, I think I like what students come up with. However, I don't want you Googling, ads and statistics, because there's a lot of stuff out there that, there's so much stuff, like new stuff. Don't go finding what other people have done and write down what they wrote for their analyses. And so again, that's, academic dishonesty if you're taking from one website and then copy pasting it into the discussion. So find ads out there, that there's so much stuff out there that, and then make sure you provide the link and then analyze it based on all the stuff that we've been talking about. So I can't wait to see what everybody comes up with, because there's always some really interesting ones, stuff that I've never seen before. And I'm like, oh my God, this is so cool. So yeah. So that'll be a fun discussion. But yeah, I'll go into discussion number 2. That's going to be after I get done with the labs, the exams and the labs, and then I'll do discussion number 2. So hopefully by tomorrow I should be done with discussion number 2. Okay. Cool deal. So we're almost out of time. Any last second questions or last minute stuff?
I think I get it now. Just again, me reviewing probability and practicing. Yeah.
Yeah, practice. Go over the lecture videos. Don't forget. the lecture videos. There's also sample problems. I work them out. I used Screencast-O-Matic, and you can actually watch me actually work those problems out. So you can see how to draw the distribution out and then work out the actual problem. So
These are your slides, right? Your PowerPoint slides.
there's actually it's these. Let me show you real quick. Leave that. Yeah, it's under PowerPoint slides in Module 2. And then if you take a look at the lecture videos in Chapter 6, see how it says sample problems with z-scores and probability? These actually walk you through the problem. So we actually show you
and probability.
Right?
Yeah, these are very.
So I actually go through the whole, you know, drawing it out and showing you, okay, so here's what we're looking for, right? So I actually show you how to sketch it out. And I circle, you know, here's the important stuff and all that good stuff. So I actually walk you through problems.
Okay.
So that's in Chapter 6. And there's 2, Part 1 and Part 2. Okay?
Okay.
Yeah, so here, if you haven't looked at these yet, it might be something to look at. Especially, it's everything that I've talked about, but I'm actually showing you how to do it. Because at home I have my tablet that I can actually do that on. Here at work I can't. So those I have to do at home.
Okay.
We have to be in a classroom.
Yes. And that's the thing is like there's pros and cons with online because like online, you know, you can just be at home and relax, but then it's like when you need questions, you're not physically in class.
Yeah, I know, I can show you. But that's why I posted these sample problems. That's exactly why I posted these sample problems. It's as if you've got me right there next to you with the whiteboard showing you, okay, so here's what you need to do, right?
Mm-hmm.
Here's what you need to look for.
Yes. But again, like I said, your PowerPoints help so much, Professor. Oh my God.
Good. I'm glad to hear that. I'm glad to hear that.
Yeah, because the book is very confusing and
It really is. Oh my God.
Really? Oh my gosh.
it doesn't even make sense. And then
Really? I'm sorry. It's actually one of the better written textbooks out there. So it's, yeah. So I've read a lot of textbooks, and this is one of the more clear. So if it's confusing, oh, I'm sorry.
So if we just go by your slides, are we okay?
Yeah, I think so. If you read through the text, I mean, there's some things that, you know, you can actually find the same information, so you can have it explained in a different way. But if it makes more sense for the lecture slides, yeah, that's fine.
Yeah. I think I spent way too much time on the first few chapters reading the book.
Yeah.
And later I found your slides and I was like, wow, what was that?
What a difference. A whole new world.
Yeah, literally, like that's what I did. Like the first couple of chapters, I was like, the book again, it gives good information. I'm not saying that like, you know, it's like
Yeah,
first book,
but it can be confusing, especially if you're not sure what it is that it's trying to say.
Then I feel like what helps me the most again is your PowerPoints, and then if I need more information about the formulas, I'll just go to the book and look at the videos that's under the
yeah, their videos are pretty good in the text. You know, so if you're not sure and you look at mine and you still need, okay, maybe I need a different explanation, you can actually look at theirs as well, and they do a pretty good job of explaining it.
How do we find their videos?
Yeah, they have videos within the textbook.
Yeah,
in the e-textbook. As you read through, there's little videos that show you and walk you through the whole process.
Oh, I bought the hard copy or the loose leaf.
Oh no.
But you should have access to the e-textbook as well.
Isn't that on the
on MindTap?
Oh, mine.
Yeah, you should have access. You'll have to look and see if you can access the e-textbook as well.
Okay, thank you for that.
Yeah, of course, no problem. All right. So
Hi.
we're good? I'm going to stop recording. Where's my little, stop recording. Pause, so lunch. So, no. Whoops, wrong one. Stop share. There we go.
Oh,
And then
I see
stop
it.
recording. All right, guys. Good luck studying.
Thank you.
Thank you again, Professor. This is so
You're
much
welcome.
helpful. Thank you.